first let's start with our today's topic. So we are going to discuss about maximizing edge AI power and cut cost with vCluster and KubeEdge. So what I mean by that, so you might have seen open source project like vCluster and KubeEdge, right? Both are amazing projects. We are going to discuss them. And today the world is all about AI. People everywhere, people talk about AIs, and edge AI is something is used in different industries. So we will talk about those industries and challenges and how you can cut cost about it. So without wasting time, let's go ahead. Yeah, so who am I? So I'm Rohit. I work as the head of developer relations at Mosia. So I handle all of the developer relations and advocacy and open source at Mosia, which is unified backend framework for a modern era, and as well as AI. I mean, it's like you can create APIs, background jobs, workflows, AI agents and stuff with Mosia, as well as you can do like one click deploy on Mosia cloud, and it is built on top of like Kubernetes and Fusion, so Kubernetes serverless. Other than that, I'm also CNCF ambassador and marketing chair for CNCF. Then I'm also GD, Docker captain, and platform engineering ambassador. So what are today's AGI challenges? So if you can see, there are like different challenges, like limited resources. So if you have used edge devices, you might have seen like the problems are there around, let's say, current AI landscape challenges, right? So today we tackle like five critical challenges, which I'm mentioning, so that are blocking your organizations from scaling edge AI effectively. So first is like resource constraints. So edge devices operate with severely limited compute, memory, and power. So traditional Kubernetes deployments are simply too heavy for those environments, right? So another thing is like you will see there is a limited resources which talk about. So edge devices have constrained compute, memory, and power resources, making it difficult to run complex AI models efficiently. So that is one of the big concern for everyone. Then security concerns. So if you have done any edge deployments, you might have seen like there is a lot of attack surfaces around. Let's say if you might have seen my talk on KubeCon EU this year, right? So that was around like how you can maintain the zero trust security in AI infra, right? So there is like different activities which happens when you work with security, deploy the models, deploy the AI things into the deployments, right? So you have to take the security measures around it to protect your sensitive data, because like 2 days back only I saw like entire npm data breach happened. So same thing happened with the previously with the DeepSeek. So someone just replaced their DeepSeek model with the PyPy package with kind of a fished DeepSeek model. So everyone downloaded it. It compromised the AWS keys and stuff. So yeah, you have to maintain the security. Another challenge is network reliability. So that is one of the big concern of everyone. So let's say if you are maintaining the connectivity between edge and cloud, it requires a solution that can operate autonomously during network outages. So let's say you have some kind of architecture where you want to connect both things, right? So network outage is very often a common thing to happen, right? And in these things, so another big challenge I would say is like high infrastructure cost. So traditional Kubernetes clusters for each edge location lead to excessive infrastructure and management cost. And another thing is like management complexity. So orchestrating AI workloads across different edge locations creates significant operational overhead. So what I mean by that, so when you orchestrate AI workloads on different architectures, so let's say you have like some AI agentic automation and you want to orchestrate it, you will use some kind of a framework to orchestrate that AI thing. And then when you deploy that on different edge locations, right, it has like it has very big challenge of us operating it. So that is like one of the biggest concern if you deal with different AI agentic kind of automations, right? So that's why, yeah, you have to check like if you're choosing this framework or choosing some tech today, tech stack today. So how you can actually scale it and how follow the operational overhead around it. And then another thing I would like to mention is network reliability. So edge locations experience intermittent connectivity, but yeah, means like your AI workloads need to keep running regardless, right? So that to be solved. So the financial impact of this thing is like you might have seen are like seeing infrastructure cost of like 80Ks for cloud only solution. Then when edge cloud hybrid approaches can deliver the same results for under $30,000. So these are the difference between the both of the things. So how we can implement the solution. So that's why we are here. So vCluster, right? So if you might have known about vCluster, just just share the link in the comments with everyone, so they can go and explore. Or means audience can explore and all. So what is actually vCluster? So vCluster fundamentally changes entire game. So think of like traditional namespaces, but with the security isolation of full clusters. So there are like couple of talks I have given already on vCluster, but yeah, I would like to mention like virtual clusters run as a lightweight pods within host cluster namespaces. So that is the thing. Then each view cluster has its own API server, etcd, data store, and scheduler. So that's what's shown here. Then the syncer component bridges virtual and host cluster resources. Then there is a resource overhead is reduced by up to 90% compared to full clusters. So you might have seen the chart of vCluster comparison with Kubernetes cluster. When I actually created it benchmark, I have seen the last benchmark. It was like around 45% to 50% kind of a cost reduction, and it will be more in the future, because as you scale the infra, you will see like virtual cluster reduces the cost. And how it actually reduces, so we will talk about it. You can see here, so host cluster goes namespaces, then namespaces have the vCluster pod, and then you have the K8s API server of your vCluster. So the magic actually entire thing happens in the syncer component. It translates the virtual cluster resources into host cluster resources while maintaining the complete isolation. You get cluster admin privileges within your virtual environment without compromising the host cluster security. So that is the one of the things. So I guess we covered entire thing from this vCluster architecture. But if you have still any doubts about vCluster, you can just add the questions in the chat box, and we will cover it at the end of the call. So that's what I said, right? So host Kubernetes clusters, and inside that there is a master node, and then your vCluster is there, which handles like different workloads. So it is quite different than you have like isolated workloads or like isolated teams. So that like if you are working with Kubernetes, you will see like different teams work on different things, right? So vCluster is sitting inside and it handles. So that's what we are saying here. So there is different things happening around namespaces. So there is namespaces, then which is your Kubernetes, then namespace as service. So that are the tools which are talking about. Then Kubernetes API as a server. So that's where we talk about KCP, and then control plane as a service as an internal. So that's where vCluster fits in the between of the control plane as a service, internal and external. So it is more efficient solution, I would say. And yeah, so then there is like a couple of other solutions around the same. So let's talk about multi-tenancy, right? So that's all. That's the one of the major goal about today's talk, right? So how actually the how actually vCluster helps. So you can run like dozens of virtual clusters on a single host cluster. So each team gets their own isolated environment with different Kubernetes versions, RBAC policies, and resource quotas. So that's what we can see here. So entire tenant workloads and your tenant workloads for the different teams can run independently in the cluster. And then there is a cluster there is a cluster of your Kubernetes cluster which has the vCluster running, which where you can deploy, you can have the service, and which is entirely ingress for you. So yeah, So vCluster benefits for KubeEdge, Edge AI is like it is lightweight vCluster, virtual cluster, so very lightweight I would say, and it reduces cost by a lot. Then multi-tenancy is there, so you will see like isolated AI workloads and teams uh, with strong security boundaries while sharing the underlying infrastructure. So that is where we talking about we already talked about it, right? So then rapid provisioning, so spinning up new environments in a second, so you just have to run the vcluster command from github repo and you will get it up in like just a seconds, I would say. I have did it like a couple of times. You can also try it. Then you have like full admin access, so you can just give your teams a cluster admin privileges within that particular virtual cluster, so they can work freely and handle any details they want from the host cluster with maintaining the security. So version flexibility is like really fast, and you can just hit upgrade and downgrade anytime, so very easy. So cost efficiency, so as I told, right, you reduce the cost around like 45% to 50% from your kubernetes workloads. So yeah, talking about KubeEdge, so KubeEdge is an open source system. So you can definitely check out in the CNCF website, CNCF landscape. KubeEdge is there, and it is open source. So it extends the Kubernetes orchestration to edge environments through a cloud edge kind of architecture. So there are like different components. So which we are talking about. So cloud core is like central hub which manages entire your edge node communication. Then there is a edge controller which handles your life cycle and metadata syncing. Then we talk about edge components, so which has like entire so whatever agents you are running it on a edge nodes, uh, it provides the lightweight kind of agent for that. And then edge hub is where you can do the WebSocket communication for your entire cloud edge. Same SD and the meta manager, which is more of like meta manager is for metadata storage and synchronization, and then HD is for like you are running some local container runtime management, so entire thing runs properly on the server, right? So one of the important thing I would like to mention here is like edge nodes operate autonomously during your network outages. So local controllers maintain AI workload execution even when you are disconnected from the cloud. So you don't have to worry about it. So that's what we discussed here. So yeah, and if you want to deploy and get started with KubeEdge, it is simple. Like you just have to run your deployment file as you do with the Kubernetes and other things, right? So what are the benefits of edge AI? Is like, so edge AI, so there are different frameworks you can use which allows you to work on edge and cloud. Then edge autonomy, so that is one of the thing. Then reliable messaging, as I told, right, it uses WebSocket messaging for like having synchronized messaging. Then you can manage devices, like you have the native management of edge devices through Kubernetes APIs, simplifies your entire deploying and monitoring AI workloads. So you can use like any open source projects to create architecture around it. I have created one of the architecture. I would definitely share it with Carla, and she can share it with you guys. Then similarly, lightweight edge agent. So it is very lightweight. You can just start agent very quickly, and so that's how you can use it at the AI at the edge, right? So because having to use AI at the edge, you need something which is efficient and lightweight and very cost efficient because it is industry need. So that's what this both tool coming together can solve the use cases. So that's what we are seeing here, right? And that's where you can see this image. It shows like how the cloud edge computing is 36% of the cost of cloud only computing when the reduction is data volume is 95%, right? So very efficient kind of a thing. When you integrate both of them together, it is like unified management. So you have like single control plane for both edge and cloud resources. Then you have the isolated tenancy because of vCluster, so secure multi-tenant environment for edge AI workloads. Then you can optimize your resources easily, right? With having like resource sharing across edge location. And yeah, another thing is like deploying on host cluster is very easy. Like one deployment file is enough. Then creating virtual cluster is easy. Like you just have to run one command and it will be like ready in like some seconds, like 50 seconds to 1 minute hardly. Then you just have to configure and deploy. So you can see this in their own documentation. You just have to go to vCluster and KubeEdge documentation. So that's what we are seeing in cost comparison is nowhere to be matched with the Kubernetes. So you will see like traditional KX is very costly when you compare it with the vCluster plus KubeEdge. So you save your infrastructure, reduce the physical infrastructure cost by up to 85%. That's what we are talking about here. Then resource efficiency, you utilize the resources by 60 to 75% through better workload distribution. And if you maintain it properly, you create nice architecture, then you can save more. I can bet on it. So then bandwidth reduction, so you can cut your cloud data transfer cost by 40 to 60% by processing data located at your edge, and you can only send what's relevant results to the cloud, right? So similarly, operational efficiency, where it yeah reduces operational overhead by 50%. So that was one of the concern from the start of our talk, right? So yeah, you can use so these are like a couple of edge AI use cases in the industries. And you can see vCluster with KubeEdge can run everywhere, and it can efficiently reduces the price rates by like so see smart manufacturing, it reduces the rate by 35% while cutting infrastructure cost by 60%. Similarly, retail analytics, so I have done some analysis to come up with this. I'm not just reading something which is already available. So you will not see these slides anywhere. So this is like my analysis of comparing both of the tools together and doing some benchmarking on it. So yeah, definitely try it out, and you can screenshot it if you want. And so yeah, so vCluster benefits is like few things which we talked about from the start. So yeah, that's all I have for this vCluster plus KubeEdge, KubeEdge kind of a combination if you do on the multi-tenancy. But definitely, if you want to ask something around particularly on this thing, then I can definitely share it around it. Yeah, thank you.
Thank you, Rohit. Um, I see you have a question here from Miguel in the chat. He's asking, can you please give a short information about resource placement with B clusters?
So means like what actually means I'm confused like what actually this who is he? Let me check Zoom message.
In the
Yeah,
chat.
Miguel. Yeah, Miguel is asking like, can you please give a short information about resource placement with vClusters? Okay, so let's say so I'm expecting you are talking about you are expecting the uh, if you have created some kind of a team based architecture before, you have worked with the worker node placement and then control plane, right? So let's say, so vCluster is something which is you don't have to worry about this thing in vCluster. vCluster lets you decide exactly where a tenant's workloads run. So you can separate them by the control plane isolation from your worker node placement. So let's say by default, a vCluster exposes all of your host cluster nodes to the tenant. So pods created in the virtual cluster are synced by syncer, right? So syncer is something which does all of the magic, so you don't have to worry about, and schedules by the host scheduler onto any machine node in the your underlying cluster. So you don't have to worry about it much. Then you can define like different kind of a models. So like shared node model, where you create like multiple vClusters which share the same physical nodes, which actually reduce your cost, and you can utilize it, right? Similarly, dedicated node model, where you can label or taint a node pool and set some node selector or toleration in the vClusters values file, which values YML file is something you will need when you run the vCluster command and set some values for it. So yeah, which will which will actually help you to separate from the physical cluster. And then it also has the V node, which is like recently vCluster launched it. So it is like creating the tenant scope virtual nodes that are mapped to your pods on the host. So which will actually give you the node level security boundaries. But yeah, if I'm at your place, I would do like a mixed approach for both of this, all of this. So like dev vClusters on shared node, then prod vCluster on dedicated GPU nodes, and then create some like combination of everything. So I guess that helps. But yeah, if you have any other questions, you can let me know.
Thank you. Okay, do we have any more questions, guys? Let's see. Let's give it a minute. Bueno, okay. So just a reminder, whoever join later, I'll be sharing with you guys the slides and the recording. Just wait for check your emails. And yeah, thank you so much, Rohit, for your presentation. It was super insightful. So yeah, thank you, and I hope to see you soon. Bye.
Yeah, thank you, thank you. Bye.